Today we're going to be talking about AS-Trig identities, and this is one of that part of this syllabus that sort of, messes up a lot of students. And I mean, it messed me up as well when I was doing my AS level papers. Thing about this is you just need to know a few identities and you need to know a few steps that you have to sort of apply to every question, and you will get it right. The first thing you need to know is a few identities. So we got the sine squared plus cosine squared equals 1. Then you got your algebraic identities. This is a minus b whole squared. Give me a sec. This is whole squared up here. Okay, and then you got your tan theta equals sine theta over cosine theta. So those are the few identities that you need to know. And then the steps are just really simple and straightforward. You need to get a rough starting point from the question. So the question is going to tell you to do a certain something that's going to sort of steer you in a direction. That's the first step that you got to do. The second step is you just got to simplify. Okay, and with simplifying, you could also be expanding. Okay, so simplifying just means do the obvious steps. You get a direction from the question, and then you start simplifying to get to that direction. And then repeat, you did that in your first step. Now you do it for the second step, third step, fourth step. You're going to get your identity how it's supposed to be. One thing, do not, and I mean do not, try and plan your steps out when you're just looking at the identity. Don't try and do that. So if you just read the question, never try to sort of plan the steps in your head that I'm going to do this, then I'm going to do this, then I'm going to do this, and it's going to lead me to this answer. That is not going to work. That is going to screw you up even more. So as simple as these three steps are, let's sort of apply them. So step one, we have a question over here, and we're going to do step one. So we need to sort of get a rough understanding, a rough starting point from the question. And well, you can try and start off with the left-hand side or the right-hand side. I'm going to personally go for the left-hand side. You can go for the right-hand side if you want to, but I'm going to go for the left-hand side. So now you can, so if I'm starting from the left-hand side, obviously I'm going to try and make it as similar as possible to the right-hand side. Now my starting points are, you can see that as I go from left to right, I won't have any sine thetas or cosine thetas. I'll just have a tan. So that's the first thing I know is get rid of tan and sines. The second thing I can see is that I have one single fraction. I don't have two different fractions. So those two are good enough starting points. You don't have to guess all of the starting points. You just need one or two starting points to know, okay, what do you got to do? Once you know that starting point, now you can start simplifying. So I'm just going to write down my problem over here. It's basically sine theta over 1 minus cosine theta minus 1 over sine theta. And see, right now, there's nothing I can do. There's no identity I can apply. There's like sort of nothing I could do at this stage. So if you don't know what to do, see, that's what simplifying means. Just do the obvious things. Okay, don't worry about, oh, I don't know how to turn this into 1 over tan theta. It's going to turn itself into 1 over tan theta. All you have to do is do the obvious things. Just say LCM, because there's literally nothing else you can do. And plus, you need one single fraction at the end. So that's one thing you can do, right? You can make it into one fraction. Essentially, this will become sine theta times 1 minus cosine theta. And one thing, don't expand the brackets. Don't expand the brackets unless you really have to. In the denominator. In the numerator, you can go ahead and expand them if you want to. In the denominator, you keep them until there's nothing else you can do. If there's nothing else you can do, then you can go ahead expand the denominator brackets. Right now, I'm just going to leave them as they are. So this is going to be sine theta times sine theta, and then minus 1 times 1 minus cosine theta. So this is basically going to simplify to give me sine squared theta over sine theta 1 minus cosine theta. And then this, you expand the other thing, so you're going to get negative 1, and you're going to get positive cosine theta. Okay, now, again, see, can you spot anything? I can, and that is basically this sine squared theta. I can surely apply an identity on sine squared theta. So I'll just do the obvious. Now, see, I don't know where I'm going with this. I don't know what's going to happen next, but I just see the obvious and I do it. I'm sort of simplifying it as much as I can. So trust the process. It's going to work. The steps are really important. Simplifying, see, the first thing was combine it into a single fraction. I understood that from judging the question, that I have to get one single fraction. So knew the first step, did the second step, I'm simplifying it, and it's going to work out. So sine squared theta is going to be 1 minus cosine squared theta, minus 1 plus cosine theta over sine theta times 1 minus cosine theta. Now this 1 is going to cancel out that one, and so we will essentially be left with cosine theta minus cosine squared theta over sine theta 1 minus cosine theta. At this stage, it's easy for a student to get confused because they can see that cosine squared theta and be like, oh, I can apply an identity to that as well. I can turn that into 1 minus sine squared theta. You don't want to do that. The reason for that is because if you do that, you just apply the identity over here on sine squared theta. If you apply the identity over here again, you will just get that same thing back. So we're not trying to do that, remember. So what do we do from here? How do we solve this from here? Because it's like we can't. There's a cosine squared theta. We can't apply that identity. Then we got denominator. We can go ahead and expand that. And well, yes, you can expand that. But I'll just say to there was this third step in the process, and the third step was to repeat. So right now I'm sort of low-key stuck with this step because there's not much I can do. So what I'm going to do is I'm going to repeat. Okay, and the way I repeat is that I look at what I have right now. I have cosine theta minus cosine squared theta over sine theta bracket 1 minus cosine theta. I have this fraction right now, and I need to sort of turn it into that 1 over tan theta. Now, first of all, what is even 1 over tan theta? So if tan theta is equal to sine theta over cosine theta, then you can essentially take a reciprocal on both sides of the equation. So you can take a reciprocal over here and over here. It's just going to be 1 over tan theta equals cosine theta over sine theta. So right now, what I need is cosine theta over sine theta. And if you go to my fraction, you can actually see that I can get that. The way I do that is because, see, there's already a sine theta in the denominator. All I have to do is somehow vanish this stuff and get a cosine theta up there in the numerator. And I don't know if you guys guessed it or not, but if you can simplify this, then one thing you can do is you can basically take the cosines out as common, and you will just see what I'm about to do in a second. So you take the cosine theta out as common, and you are going to get 1 minus cosine theta over sine theta, and you get 1 minus cosine theta over here. Okay, so now this thing and that thing are going to cancel out, and I have my cosine theta over sine theta, which is going to be 1 over tan theta. Now, see, the question was sort of hinting to you what you have to do, because if you come back to this step right over here, then they already give you a sine theta in the denominator, and you already have cosines in the numerator. So what you have to do is you have to sort of think about how can I get rid of this thing. And well, if you want to get rid of this thing, then one thing you can do is you can cancel it out. But you need the same thing in the numerator as well. So I just tried to produce that same thing in the numerator. So again, what are the 3 steps? Got a rough starting point from the question, started to simplify, and then if I got stuck, I just repeated the process again. As simple as that. Okay, now going on to part 6. Part 6 says tan squared x minus sine squared x. We need to show that this is equal to tan squared x sine squared x. Again, you can start off with the right side or left side. That's up to you. I'm going to start off with the right side. Usually when you get your AS level questions, they do sort of make the questions in a way that it's more sort of easier to start off and solve from the left-hand side as compared to the right-hand side. But that said, there's nothing wrong with doing it the other way around. So right now you have tan squared theta, you have minus sine squared theta. You have to turn it into tan squared theta multiplied by sine squared theta. That's not as obvious. You don't really have any idea what to do over here. You have tans and sines on the left side. You have tans and sines on the left side. The only thing you don't have is a negative sign. So somehow, basically somehow, I have to get rid of that negative sign. Now, as of now, I don't know how to do that. So I'm just going to write tan squared x minus sine squared x. And again, in the previous problem, when I was on my first step, I didn't really know what to do. What I did was I just combined both those fractions. So over here, I really don't know what to do. I guess one thing I can do is I can basically write tan a different way, because that's literally the only thing I can do. So see, right now you may be thinking, how do I take this thing to that thing? And that's where you sort of get stuck, because you're with identity problems, you want to think less, do more, and it's automatically going to solve itself. Trust me, you have to trust the process. That's super important. So I'm just going to go with sine squared x over cosine squared x. As of now, even I don't know how this is going to turn into my answer, but I'm just randomly going to try it out, and something is going to work. So minus sine squared x. Okay, I still don't know what to do, but I can take the LCM, I guess. That's what feels most natural to me. So it's going to be cosine squared x, sine squared x minus sine squared x cosine squared x. Okay, this is what we have so far. Now, what we can sort of do is, see, I really don't have no clue. So I'm showing you guys how we can sort of, do questions like these if you have no clue and you're sitting in the exam. One thing I guess you could do is you could, okay, so here's what I'm going to do, and I'll tell you the reason as to why I'm doing it. I am going to, wait, I genuinely don't know what I'm going to do over here. So I'm going to go back to the question and see, this is what I have to do. I have to somehow get rid of the minus signs. I have to get this one thing to multiply with this other thing. So technically, tan squared x times sine squared x is the same as sine squared x over cosine squared x times sine squared x, right? And I can write this a different way, or this would be just sine raised to the power 4x over cosine squared x. See? So what I'm trying to do is I'm somehow trying to get this thing over here. So now again, I'm repeating. I'm back to the first step. The first step is analyze. The first step is compare what you have to what's given in the question. And so I have this fraction. I sort of need to turn it into that thing. That's what I'm trying to do. And I'm going to try and think of a way that I can simplify my stuff to get the answer. So what can I do over here? How can I get a sine to the power 4? Okay, yes, I know how I could do that. Okay, this is what I need to expand. This is what I need to expand. I need to change this into 1 minus sine squared x. And you may ask, well, why? See, I'm trying to get that sine to the power 4, right? If you go over here, that's what I'm trying to get, this guy, sine to the power 4. I already have a sine over here. So if I change this cosine into that sine, this squared is going to be multiplied with that squared. That's where I'm going to get that 4 from. So that's what I'm going to do. Okay, so I got sine. So see, again, I compared my situation to the answer, and now I'm simplifying it to somehow get that sine to the power 4. And then we'll see where we go from that. I have no idea where we're going to go from that. This is sine squared x minus sine squared x times 1 minus sine squared x over cosine squared x. Okay, so this is going to simplify to sine squared x minus sine squared x plus sine to the power 4x over cosine squared x. Okay, you can clearly see how we're going to get that answer right now. Okay, so I'm still simplifying. Cancel, cancel. I can write this thing differently. I can write this as sine squared x times sine squared x over cosine squared x. And I can turn all of this into tan. I'll get tan squared x times sine squared x. See? Simple as that. Again, I didn't know how to solve this beforehand. I had no idea how I was going to turn this into the final form. But again, you just keep on applying the steps, keep on simplifying, keep on comparing, repeat the process, you will eventually get there. We got 1 minus tan squared theta over 1 plus tan squared theta, and we need to show that that is equal to 1 minus 2 sine squared x. And see, again, you could choose if you want to start from the right-hand side, you can choose if you want to start from the left-hand side. Usually, again, with these questions, it's just way easier to start from the left-hand side and turn it into the right-hand side. So, that's what I'm going to recommend. So you got this thing, and you're trying to convert it into 1 minus 2 sine squared 2 sine squared x. One thing that you can, just see right off the bat is you don't have any tans in your answer. The second thing that you can see is you don't have any fractions. So those are two starting points. Get rid of the tans, get rid of the fraction. That's a good starting point. So how do we get rid of the tan? Well, we know what tan is equal to. Tan x is equal to sine x over cosine x. And so if we have squared, then it's just going to be tan squared x is equal to sine squared x over cosine squared x. And so what we can sort of do is we can write this as 1 minus sine squared x over cosine squared x. And I'm going to remove the fraction. I'm going to write the fraction as this. This is going to be 1 plus sine squared x over cosine squared x. The reason I did that is because if you keep the fraction, it's going to become really mumble jumbled. It's going to be a fraction within a fraction within a fraction. So this is just an easier way of doing things. Okay, we can sort of expand the insides of the brackets. So this is going to be cosine squared x minus sine squared x. I'm just taking LCM over here. Cosine squared x. Okay, yeah, I think that's it. And then this will be cosine squared x over cosine squared x. We'll have plus sine squared x over here. Okay, now what you can do is, if you have a division sign, you can turn it into a multiplication sign and then take the reciprocal of the fraction. So this thing, this thing is just going to turn into a multiplication sign, and you're going to have this thing reciprocal itself. So it's going to be this. Now what you can see is that this cosine cancels this cosine. That's good. And then what you'll have is you'll simply just have cosine squared x, and you'll have cosine squared x plus sine squared x. So you got one fraction now. And what you're supposed to do is, again, I don't know what to do over here, just because all of these are squares, and I can apply the identity on almost every single one of these, but I want to be sure that when I apply the identity on one of these, it leads to a meaningful result. What's the point of applying an identity if I don't even know what's going to happen? So I go back to my question, and I see what I'm trying to do is I'm trying to get 1 minus 2 sine squared x. What that means is that I'm trying to get rid of all the cosines. Right now I have cosines. I'm trying to get rid of all of those cosines. I need sines, just sines. So what I can do is the first thing I can see over here is that I can apply an identity. Now, I don't know if that identity is going to have a meaningful result or not, but when you can apply identities, usually they do have meaningful results. And so cosine squared x minus sine squared x is basically cosine x plus sine x, and then cosine x minus sine x. And I'm hoping that this has a meaningful result. And it actually does. Does it? Does it have a meaningful? No, it actually doesn't. As of now, it doesn't. Cosine squared x plus sine squared x. Okay, what do I do from here? Can I figure something out? Can I figure something out? I think not. I think I can figure something out. Okay, I don't think applying the identity was the best way to go about this. Okay, you know what? We're not gonna apply the identity because I think it didn't do anything useful. I think we just got stuck at the end. So one thing that we can do is if we go back to the question statement, we can sort of steer ourselves into a direction, and that direction is that basically we have no cosines. So let's get rid of those cosines. This is gonna be 1 minus sine squared x minus sine squared x, and then we're gonna get 1 minus sine squared x plus sine squared x. And see, the question just solved itself. So this is going to cancel out. These two guys are going to cancel out. And so you're going to be left with a denominator of 1. And whenever you have a denominator of 1, that just means you don't have a fraction. And so what you have now is this thing, and they both have a negative symbol. They're going to add up, and you're going to have this thing.